All right, so I'm going to show you a couple examples here on our stoichiometric conversions. So we start out here. I'm going to show you number one. And the first thing that we should always do is we should balance the chemical equation. So I start out here and I have 1 potassium on my left and I have 1 on my right. I move to the next item here, are Cls. I have 1 on the left, 1 on the right. And then I move to my oxygens. I have 3 on the left and 2 on the right. So remember that trick I've taught you about the 2-3 combo. We need to get to 6 is what that means. So what times 3 equals 6? Well, that is a 2. Over here, again, we're trying to get to 6. So what times 2 is 6? Well, that is a 3. And now we have to go back and recorrect our potassium and our chloride in our equation. So because we have 2 potassiums, we need 2 potassiums, so we put a 2 out in front and we are balanced. Now we can go through and we can actually write our stoichiometric calculation. So it says how many moles of O2 oxygen are produced from 10 moles of potassium chlorate, or KClO3. So we always start out by writing down what is given out of our equation. So right now we have 10 moles of KClO3. Now we set up our conversion and we need to cancel out diagonally. So we have moles of KClO3 on bottom, and on top we can convert to what we want to, but it needs to be in moles, which is good because that's what the question asks. Now, whenever you see mole over mole, what we do to find our numerical values that go in these places is we look to our balanced chemical equation. So for O2, we look at O2 and we notice here that there are 3 as our coefficient, and that coefficient number goes right on top next to O2. Now we do a very similar thing for KClO3. Again, we look at the coefficient and we place that coefficient in that particular slot in our conversion. So we put a 2 because it had a 2 coefficient. We put a 2 down here. So what we're going to do is this. We're going to take 10 times 3 and then divide it by 2. So 10 times 3, 10 times 3, and then we're going to divide that by 2. And our answer is 15. So this becomes our answer. And we will box that in. Now, the other type of problems, 2 and 3, follow a very similar format. They use the same balanced chemical equation. All right, so I also want to show you number 4. It's a little bit more wordy, and it says the carbon dioxide exhaled by astronauts can be removed from a spacecraft by reacting it with lithium hydroxide. An average person exhales about 20 moles of CO2 per day. How many moles of lithium hydroxide, LiOH, would be required to maintain 2 astronauts in space for 3 days? Balance the equation below and perform the correct stoichiometric calculations to determine the number of moles, LiOH, would be required to maintain 2 astronauts in space for 3 days. So again, the first thing that we have to do is we have to balance our chemical reaction. So over here on the left, we have 1 carbon. On the right, we have 1 carbon, so they are balanced. Over here on the left, our oxygens, I'm going to save that to the end, and you'll see why. We move over here to our lithiums. Our lithiums, we have 1, and on our right, we have 2. So to make this a 2 on the left, we put a 2 coefficient. And then we move to our hydrogens. We now have 2 H's on our left and 2 H's on our right. So now we're going to come full circle back to our oxygens. On our left, we have these 2 oxygens from CO2 plus 2 times 1, So another 2. So total, we have 2 plus 2, which is 4 oxygens on our left. On the right, we have 3 oxygens from CO3 plus 1. That equals 4. We are now balanced. Now, here's the reason I wanted to show you this particular problem. Number one, I want to show you this. Each person is going to exhale 20 moles of CO2 per day. So I'm going to write this down as 20 moles CO2, and then below here I'm going to write down per day. Well, that is per person. We have 2 people, so we multiply this by 2 people. And these 2 people are up here for a total of 3 days. Okay? So this helps us get our initial amount of CO2. So we have 20 moles times 2 times 3. So 20 times 2 times 3 equals 120 moles of CO2 exhaled in total by each of those 2 astronauts for those total of 3 days. Okay, so this becomes our amount of moles CO2. We want to convert it over to moles of lithium hydroxide. So we're going to start out by writing 120 moles of carbon dioxide, and we want to convert it to moles of lithium hydroxide. So we cancel out units of moles CO2 on the bottom right, and on top we can actually put our moles of LiOH. Now, whenever we get mole over mole, the way we find our number value there is we look to our balanced chemical equation. So the coefficient designates how much or what we need to put in our value here. So because we have a 1 in front of CO2, we put a 1 down below with CO2. And then LiOH, we have a 2 coefficient. So that means we need to put a 2 coefficient in here. So when we calculate this out, we're going to take 120 times 2 divided by 1. So 120 times 2 divided by 1. And that equals 240 moles of LiOH. And I will box that in. All right, so that's how we go from moles to moles. Again, I want you to do problems 2 and 3. We're going to move on to another problem here. All right, so this one, these 3 problems are going to go from moles of a starting substance to mass of another substance. So remember, the first step is always the same, and that's balance that equation. So I'm going to show you how to do number 5, and then I want you to do 6 and 7 on your own. So number 5 says, some of the sulfur dioxide released into the atmosphere is converted to sulfuric acid according to the equation written below. Determine the mass of sulfuric acid formed from 3.2 moles of sulfur dioxide. So again, the first thing that we have to do is balance the chemical equation. So we start out here with our S for sulfur. We have 1 on the left, and then on the right we also have 1, so they're balanced. Oxygens I'm going to skip for right now, and then I'm going to move over to H's. I have 2 H's on the left, 2 H's on the right. Okay, so we're even, we're balanced there, and we can move to our oxygens. So right here I have 2 oxygens plus 1 other oxygen. So that's a total of 3. Over here I have 2 oxygens plus 4 oxygens. That gives us a total of 6. So no matter what we do here, we're never going to get 6. So what we need to do here is a couple of things. I'm going to go ahead and I'm going to make this an even number of oxygens. So now I have an even number of oxygens, but I still don't have 6. I have a total of 4. So how many more do I need to get to 6? Well, 2. So that's going to be my coefficient in front of SO2. Now by doing this, what I have done is I have doubled the amount of sulfur. So what I need to do here is I need to put a 2 in front of the sulfuric acid. And so this equation is balanced. Again, be careful here. This is the reaction arrow. So just to walk you through the balance, we have 2 sulfurs. Oxygens, we have 2 times 2, which is 4, plus 2, which is 6, plus another 2, which is 8. So we have 8 oxygens on our left, and then 2 times 4 is 8 oxygens. And then our hydrogen, we have 2 times 2, which is 4, and 2 times 2, which is also 4. So this equation right here is balanced. I know I was a little off there at the beginning, but this equation is balanced. The other thing that we're going to need is the molar mass. Now, the molar mass that we're going to need is sulfuric acid. And you could do this one of 2 ways. You could actually go through and calculate the molar mass of sulfuric acid, or if you Google this particular formula, H2SO4 for sulfuric acid, you'll find that the molar mass is 98.03, and we're going to have to utilize this. So how we do this stoichiometric calculation is this. We always write down what we're given. So we have 3.2 moles of sulfur dioxide. So we have 3.20 moles of sulfur dioxide. And we need to get it to grams of sulfuric acid. So we start out here and we cancel out the same unit. So we cancel out moles of SO2, and we want to go to sulfuric acid. So I'm going to write that down, H2SO4, but we have to go to moles of sulfuric acid first. Remember, with mole island, you can only go from one substance to another when we're in units of moles. So where we get our values here when we have mole over mole is our balanced chemical equation. So for SO2, the coefficient in front of that is 2, so we put a 2 down in front. And then for sulfuric acid, the coefficient is also 2. Now we're not quite done because we're just in moles of sulfuric acid. So our last step here is to convert our moles of sulfuric acid to grams. So we can go from moles to grams. Now, you need the molar mass, which I gave you in this particular problem to be 98.03. So that 98.03 number goes on top here, and that's for every 1 mole. So what we're going to do here, we're going to multiply out 3.20 times 2 times 98.03 divided by 2 times 1. So 3.2 times 2 times 98.03, and then we divide that by 2 times 1. And we get our value here, and we can round this. I'm going to round this to 314 grams of sulfuric acid. Okay, so the key thing here is balance your chemical equation and then look up the molar mass of the substance that you are converting to. Again, you can Google this, or you can walk through the motions of finding your molar mass on the periodic table and adding them all together like we traditionally do. All right, so we're going to shift gears here. We're going to go to our last set of problems here, and we're going to go into mass-to-mass conversions. I want you to do 6 and 7 on your own. Okay, so mass-to-mass conversions. Again, the thing here is there's going to be 3 conversions, and we always start in the same place, and that is balance the chemical equation. So I'm going to do number 8, and then I want you to do number 9 and 10. So number 8 says, if 40 grams of magnesium reacts with excess hydrochloric acid, how many grams of magnesium chloride are produced? So first things first, always balance our chemical equation. We have 1 mg on our left, 1 mg on our right. They are balanced. We have an H, 1 H on our left, and on our right we have 2 H's. Okay, So we need to put a 2 coefficient in front of our H. So now we have 2 Cl's. Now we have 2 Cl's. Okay? We are balanced at this particular point in our problem. So what we do here is this. We need the molar mass of not only magnesium, but also magnesium chloride. Now I went ahead and I looked these values up, and the value for magnesium in terms of the molar mass is 24.31 grams per mole. And for magnesium chloride, the molar mass is 95.21 grams per mole. Again, you can do one of two things. Google the molar mass of these particular substances, or you could do the traditional method where you look on the periodic table and you look at the individual elements molar mass and you add all of those involved in the formula together. All right, so now we have our starting substance here of 40 grams of magnesiums. So we start out with 40 grams of magnesium. And what we need to do here, we need to get rid of our grams of magnesium. So our first thing that we get rid of diagonal, we cross cancel diagonal to get rid of grams of magnesium. And what we need to do first on these problems, we need to convert to moles of that same substance. So it's moles of magnesium. Now what goes with our grams is the molar mass of magnesium. So we're going to put 24.31 grams of magnesium, and that is for every 1 mole of magnesium. Now, that is one of 3 conversions that we have to do. So we start out here, and now we're trying to go from moles of magnesium to moles of magnesium chloride. So we cancel out moles of magnesium on bottom. On top, we put moles of magnesium chloride. Again, we can convert from one substance to another as long as we're going from moles of something to moles of something else. Now, mole over mole, the way we find these values here is through our coefficients in our balanced chemical equation. So in our balanced chemical equation, in front of Mg, there is a coefficient of 1. And in front of MgCl2, there is a coefficient of 1 as well. Now, what we need to do, one step further, because we want grams of MgCl2. So we cancel out moles of MgCl2, and on top we can finally get to grams of MgCl2. Now, what we need to do is we need to put the 95.21 number associated with grams. So 95.21 grams per every 1 mole. And we will go through and we'll calculate. So we're going to take 40 times 1 times 1 times 95.21 divided by 24.31 times 1 times 1. So 40 times 1 times 1 times 95.21. We press enter, and then we divide it by 24.31 times 1 times 1. Close that parenthesis, and we press enter. We get a value. I'm going to round to 3 significant digits. So we get a value here of 157 grams of magnesium chloride. And that becomes our answer. Okay, the key on these is to balance your chemical equations first and look up the molar masses of the 2 substances that are involved in these types of equations. I want you to do 9 and 10 on your own, and any problem I did not do in this video.